this video is just a brief overview of which method for solving quadratics would be the best method to use and why. So it would be solving quadratics best method. The roots of the equation are the point where the parabola crosses or touches. So crosses or just touches the x-axis. This is also so when y is equal to 0. So there are many methods to use. The first one that we're going to talk about is solve by factoring. Solve by factoring is a method that cannot always be used. This is used if the equation can be factored easily. You can also check to see if it can be factored before you do any of the math by checking if your discriminant, which was that b squared minus 4ac, so if you plug in your b squared minus 4ac, is equal to a positive perfect square. The fact that it's a perfect square is what makes it factorable. Or if it's equal to 0. That means that the problem will be able to be factored. And here are the steps of factoring. So you'll write the equation in standard form. You'll factor the quadratic equation either by difference of squares, MACAD. Then once you have them factored, you'll use a zero product property. So once your parentheses are separated, set each parenthesis equal to 0 and solve for the variable. What that means is anywhere you have a variable of x, you're going to set that equal to 0. And remember, factor, you always do your GCF. Then you're going to check each of the roots in the original quadratic equation to make sure that they actually worked. Solve by factoring will not always work because not all quadratics will cross the x-intercepts or cross the x-axis. The second method is called solve by quadratic formula. Now, the quadratic formula, used if the equation is not easy to factor, this method will always work because even if it gives you imaginary solutions, you will always be able to find your solutions. This method will always work. For ax squared plus bx plus c equals 0, the value of x is given by the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where b squared minus 4ac is the discriminant. This goes back to up here on solve by factoring. So if you figure out your discriminant first and you notice that it is not a positive perfect square, you can automatically go straight into the quadratic formula. That's one of the reasons why you check the discriminant first. So again, this method will always work. If your discriminant is not a positive perfect square, you already have half of the quadratic formula done. So you can go straight into the quadratic formula. So the discriminant determines how many real or imaginary solutions a quadratic equation will have, and also rational and irrational. So if your discriminant is a positive perfect square, just a positive perfect square, you will actually have two real, because of the positive, two real, and because it's a perfect square, you'll have two real rational. If your discriminant is just positive, so it's not a perfect square, that means it could not factor, then you'll still have two real, but since it wasn't able to be factored, you have to use quadratic formula, it'll give you irrational solutions. So that means it's going to be like the square root of 3. If your discriminant gives you a value of 0, because 0 is neither positive or negative, but you can take the square root, you'll still have real, but the square root of 0 is 0, so you only have one real. Now, whenever you add 0 or subtract 0, you get the same answer. That's why you only have one, and it will be rational, because you won't have those pesky decimals. Now, if your discriminant is negative, it doesn't matter what type of number it is, if it's negative, regardless of perfect square or not, if it's negative, you will still have 2, but they will no longer be real. They will be imaginary. And think about imaginary, they cannot be rational or irrational. They are just imaginary. So again, if you find your discriminant first, you can easily determine if the quadratic would be factorable. But if it's not factorable, you can go straight into the quadratic formula, which is why you find your discriminant first. The next method you can use is the square root. Again, solve by square root will also not always work. You use solve by square roots if there is no b term or already in vertex form. Basically what that means is that you have just one letter in the problem. That does not mean that you have X, the letter X, multiple times. That means you literally have the letter X written one time in the problem. So if you can isolate the quadratic term such that there is only a constant on the right, just take the square root of both sides. Let's remember to put plus or minus in front of square root when solving. So whenever you take the square root of a value, you have to put the plus or minus in front of it. So again, there is only one letter X in the problem, just like it would be in vertex form. The next one is completing the square, which is right here, solve by completing the square. This method will also always work because technically completing the square converts it to vertex form, which all quadratics have a vertex, which is why it will always work. Now you use solve by completing the square when your A value is already 1 and your B value is an even number. If it's already like that, solve by completing the square is going to be much easier. You're going to isolate the constant. You're going to use your workbox, which is half of b, and square that value. You're going to use your arrows, so you're going to end up adding that half of b and squared to both sides of the equation. And you're going to factor that trinomial. So once you have factored the trinomial, you're going to solve for x by moving everything to the right using SADMAP, which is PEMDAS backwards, to order of operations. So again, that's moving everything to the right. And then basically what you're doing is when you are solving by completing the square, you're actually going to be using square roots, which is why these are put together. Because if you solve by completing the square, you will end up using square roots. But you use this when your A is 1 and your B is an even number, so you can take half of B. The last method that you can use is solve by graphing. Now, this also will not always work because to solve by graphing, it has to be crossing the x-axis, and not all quadratics will cross the x-axis. So right now we have two methods, quadratic formula and completing the square will always work. Because this one will give you your imaginary answers, and this one converts it to vertex form first, and all quadratics have a vertex. So this, solve by graphing, doesn't always work. Step 1, you're going to plug the equation, your equation, into y1, and you're going to make y2 equal to 0. You're going to press graph, or if you need to, press zoom 6. Press zoom 6 if your graph is zoomed out or anything. Once you have it to your graph where you can see your two x-intercepts, you're going to press second trace 5, which is going to be your intersection. This will calculate the intersection of the equation and the x-axis. So you're going to do second trace, you'll do number 5, intersect. Once it goes back to your screen of your graph, you're going to move your cursor to the left or right to get to one of the x-intercepts. Once you get there, or you get close to it, you'll press enter 3 times. So enter, enter, enter. Then what it'll do is it'll give you a solution. It'll be x equals, and then it should be y equals 0. Then you'll have to repeat steps 3, 4, and 5 for the other x-intercept. So this is just a quick overview of which method to use and when. So again, quadratic formula and completing the square will always work, but these could be more difficult to use because it can be time consuming. Completing the square should be used only if A is 1 and B is an even number. That's when you should use that one. Completing the square will work on every single problem. However, it can be time consuming and you will have to simplify radicals. Not always the best method. But also, if your directions say to solve by factoring, you must use factoring. If it says solve by quadratic formula, you must use quadratic formula. So you must read the directions and know which method to use. And then you can always come back to here and check how to do the problem.